I wanted to build a smartwatch, but the problem is, I knew absolutely nothing about electronics. I had some experience with microcontrollers, but I had never learned how it works under the hood. So instead of starting with something simple, I decided to design a custom smartwatch around RP2040, the same chip that runs Raspberry Pi Pico. Since I know nothing about electronics, I had to learn them, understand every symbols such as ground, 3.3 volts, resistors, while also using the RP2040 datasheet to check for the necessary component to make the chip work. Eventually, I had the schematic, and that meant it was time for the next problem, laying out the actual PCB. Despite many rules, my first attempt was just placing everything onto the board, which is pretty awful, for either wiring them together or just simply making it work. On my second attempt, I've learned my lesson and started placing them in order. For example, every power pin should have a capacitor next to it to protect the pin from getting fried. Laying them out is the easiest part, while wiring them took me days, since it's more like a maze. You gotta connect point A to point B without disturbing the connection before. For the power trace, I used wider trace than I used for most signal connections, because power traces may need to carry more current and benefit from lower resistance. After all that and some debugging, I ordered the board. And while waiting for the board, I also programmed a round LCD screen with a Raspberry Pi Pico to emulate a smartwatch. With the arrival of the board, it's time to assemble it. I use what we call a SMT, which is surface mount technology, to assemble the components. It works like this. By using a stencil to spread the solder paste onto the PCB, then place all the components onto the board. After laying them, just heat it up. While the process is pretty clear, there are still some ways to fail this project. In my first attempt, I have placed the power management in the opposite direction. The second one failed because I didn't clean the stencil properly, so some of the holes weren't applying solder correctly, causing the paste to form giant blobs, create short circuit, and burning the connector. After multiple failures, burning every board I touch, on the third attempt, with careful soldering and placing, it finally worked. Oh my god! Okay, let's go. It's not burning. Although this is a pioneering moment for me, but that didn't mean I succeed, since at this point I finally realized I didn't make a boot button for the chip. The only reason the USB will show up is because the chip is empty. Without the USB port, I won't be able to insert any commands, which is exactly what happened. After I plugged the round USB into it, I tried connecting the boot pin directly to ground, but without a resistor. You should be very careful not to accidentally press it after plugging in, or the board might burn down. Well, just like this. Looking back on this project, there are still a lot of things I could improve. I also didn't explain every technical detail in the video, since that would made it way too long. But I learned a lot from this journey, especially how microcontrollers work in detail, and how to design one myself. These skills allow me to make more complex projects in the future. Even though I didn't succeed in making the watch, I still think this project was worth it.